this video is a combination of two lessons, the vertical asymptotes lesson in Edgenuity and the graphing rational functions. So when you have a rational function, it's just a fraction. So you have something on top and something on the bottom. But on the bottom, there always has to be a variable. That's what makes it a rational function, is you have to have an x in the denominator. So you're going to have an x-intercept where p equals 0. So that means if you can figure out what makes the top 0, that will give you an x-intercept. You will have a vertical asymptote where q equals 0. So you're going to have a vertical asymptote with what makes the denominator, or the bottom, 0. And that will give you a vertical asymptote. So when you have a vertical asymptote, you absolutely cannot cross it. So it's one that goes up and down. The reason it's a vertical asymptote is because you can't divide by 0. So it's whatever makes the bottom 0. And again, you can never cross a vertical asymptote. So up and down one, you can never go across it. Now, a horizontal asymptote is a little bit different. So the way we decide what your horizontal asymptote is if the degree of the top, and remember the degree is the biggest exponent. So if I had like x cubed plus 2x squared, that would be degree 3, because the biggest exponent would be a 3. So if the degree of the top is less than the degree of the bottom, you have a horizontal asymptote at 0. So it's essentially just the x-axis. So a horizontal asymptote through 0. If the degree of the top equals the degree of the bottom, then what you do is your horizontal asymptote is the leading coefficient of the top divided by the leading coefficient of the bottom. So what that means, I guess I'll give an example for all of these really quickly. So what I was talking about here, if the degree of the top is bigger than the degree of the bottom, if I had like x over x cubed plus 2, this is degree 1, this is degree 3. So 1 is less than 3, so we'd have a horizontal asymptote at 0. This one here, let's say we had 2x squared plus 7 over 3x squared minus 4. So degree is 2, degree is 2. So they equal each other. So then what happens here, your horizontal asymptote, like I said, leading coefficient is just the number in front. Your horizontal asymptote here would be 2/3. So if the degrees are the same, you just use the numbers in front to help you figure out what your horizontal asymptote is. Now let's say the degree of the top is greater than the degree of the bottom. So if I had like x to the 4th plus 2x over x minus 3, so I'd have degree 4 over degree 1, so 4 is bigger than 1. There is no horizontal asymptote. Okay, so when you graph, these are the steps that you need to follow. First thing, you need to factor anything that you can factor. That's the first thing you're going to do. The second thing you're going to do is figure out what your vertical asymptotes are. So again, what makes the denominator 0? Then you're going to use these things here to help you figure out what your horizontal asymptote is. Then you're going to figure out your x-intercept. So what makes the top 0? Then you're going to find the y-intercept. And the way you do that is you just plug 0 in and see what you get. And that will give you your y-intercept. And then from there, you might need a table to come up with more values of where you're graphing. Okay, so for our first example here, graph -8 over x squared minus 4. So step 1, we're going to factor. Nothing we can do on the top, it's just a -8. But in the denominator, this is a difference of squares. This is x squared minus 2 squared. So the way that difference of squares always factors is x plus 2, x minus 2. Okay, so that's how that one factors. Next, we're going to figure out what our vertical asymptotes are. So what makes the bottom 0? Okay, so when you have something like this, what's going to make it 0 is if x plus 2 equals 0 or x minus 2 equals 0. So we are going to have vertical asymptotes at -2 and +2. Third thing we're going to do is we're going to figure out what the horizontal asymptotes are. So what's the degree of the numerator? There's no variable in there at all. So it's actually degree 0 if there's no variables. Now in the denominator, the biggest exponent is a 2, so that's degree 2. So 0 is less than 2, so top is less than bottom. Top is less than bottom, so we have a horizontal asymptote at 0. Next thing we're going to do is we're going to find the x-intercept, and that's what makes the top 0. X-intercept makes top 0. So what you would do is you take the numerator and set it equal to 0. Well, like I said, we have no variable in the top, and this doesn't make sense. -8 doesn't equal 0, so that means here we have no x-intercept, if that ever happens. And step 5, we're going to find the y-intercept. And the way we do that is you plug in 0. So -8 over 0 squared minus 4. So we get -8 over -4, which is 2. So that means I have a y-intercept at 2. So let's stop there and plot all the things that we have. So we have, like I said, we have vertical asymptotes at -2 and +2. We have a horizontal asymptote at 0. So I'm going to put it just a hair above my line so you can see that it's there. We have no x-intercept, but we have a y-intercept at 2. Okay, so once you get there, what you want to do is make a table of values to figure out what's going on all the sides of the vertical asymptotes here. So basically, what I like to think of is we have 3 sections of the graph. The horizontal asymptote is not absolute. You can go across it. Vertical asymptotes are absolutely, do not go across them. They are stuck. You can't go, the graph can't touch them. So we have a section over here on the left of this vertical asymptote, a section here in the middle, and then a section on the right. So what I'm going to do is I'm going to test a point in each of these 3 sections to see where it's at. Okay, so over here, I'm just going to choose an x value that's on the left. So if our vertical asymptote is -2, I'm just going to choose -3. And again, our equation was -8 over squared minus 4. So if I plug in -3, I'm going to get -8 over -3 squared minus 4. That's 9 minus 4. So we get -8/5, which is about -1.6. So that means when I'm over here at -3, I'm down about -1.6. So left 3, down 1.6. So what that means is this part of the graph is stuck in this section here. It can't go across the vertical, and normally as it goes outwards, it won't go across the horizontal. The inside part, the horizontal asymptote, is tricky. So if I'm stuck in this corner down here, the way the graph has to look is this has to go down forever because you cannot go across it. And then this curves out, and as you approach infinity, you also will not go across your horizontal asymptote. Now let's see what's going over here on the right at +3. So this is +2, so I'm going to just see what happens at 3. Same thing, negative 8/5. So it is also stuck down here in this corner. So at positive 3, we're at negative 8/5, which is about there. So again, stuck down in this corner here. So the way it has to go is it has to go down forever, and then it levels off here at our horizontal asymptote. Now, when we're looking at the middle, what I like to do is I like to try 1 point on either side of our y-intercept here, because sometimes they'll both go in the same direction. So like these would both go up or they would both go down. But sometimes you do get where one side goes up and one side goes down. So I'm going to test out -1 and +1. So if I plug in -1, so -8 over -3, which is a +8/3. And if you're ever unsure like where that is, just plug it in the calculator. 8 divided by 3 is about, 3 goes into 8 twice with 2 left over, 2.6 repeating. And then if I plug in +1, same thing, -8 over -3, which gives us, again, a +8/3. So we get the same thing. So at 1, we're at about 2.6, and at -1, we're also 2.6. So they're going to go up. And that's how you graph a rational function.